How can a small moon orbiting so far from the Sun possibly be the most volcanically active body in our entire solar system? That place, right out there, is Io, a world constantly reshaping itself with fire and brimstone. Despite being farther from the Sun than Earth, Io is perpetually plastered with hundreds of massive, active volcanoes. The landscape is a bizarre, alien canvas painted with brilliant yellows, reds, and whites from strange volcanic compounds. So, if the Sunday's meager warmth isn't the power source, what is keeping this moon so incredibly hot underneath its crust? The answer lies not in solar radiation, but in the colossal gravitational squeeze from its massive parent planet, Jupiter. Io is trapped in a powerful gravitational tug of war, caught between Jupiter and its larger neighbors like Europa and Ganymede. This constant gravitational flexing creates intense internal friction, effectively kneading the moon like dough. That immense tidal flexing generates unimaginable internal heat, enough to melt solid rock deep within Io's interior. This heat has nowhere to go but up, forcing vast quantities of magma and sulfur dioxide out through surface vents. Imagine landscapes featuring lava lakes, some larger than entire terrestrial seas, constantly churning and boiling. The eruptions aren't gentle. They launch plumes of volcanic material, hundreds of kilometers high into space. When these plumes collapse, they deposit fresh layers of colorful, sulfurous snow across the entire surface. Io boasts the tallest mountains in the solar system, towering peaks sculpted not by plate tectonics, but by uplift from below. These mountains stand starkly isolated against the dark, tortured plains, a testament to pure internal power. The heat creates incredibly dynamic environments, where surface features can change dramatically in just a few weeks. Io essentially serves as a massive, natural laboratory, demonstrating the extreme limits of planetary geology. By studying how Io dissipates internal energy, scientists better understand thermal processes on countless other worlds. Understanding Io's fiery engine helps us refine our models for Earth's own deep, mysterious geological engine. Future missions planned for the Jupiter system promise to unlock even more secrets about this unique, chaotic world. What new materials or energy sources might we find when we get a closer look at these extreme sulfurous vents? Perhaps Io holds clues to how life might survive in subsurface, high pressure, high temperature environments elsewhere. It's a wild reminder that even in the dark outskirts of our own solar neighborhood, unbelievable heat and energy thrive. Think about that powerful gravitational dance happening millions of miles away, constantly fueling Io's inner fire. The sheer scale of volcanic activity on Io is a humbling benchmark for what geologically active truly means. Every eruption is a snapshot of a process that has been relentlessly at work for billions of years. These intense forces shape a world entirely unlike our own peaceful, Sunday-warmed Earth. Io proves that proximity to a star isn't the only prerequisite for incredible internal heat and dramatic geological change. We are just beginning to map the surface features created by these constantly churning subterranean furnaces. The colors on Io are not random. They are chemical signatures telling us exactly what is happening beneath the crust. Scientists look for evidence of past eruptions to build a comprehensive timeline of Io's entire tumultuous history. Consider the energy output. Io is a powerhouse, radiating more heat from its interior than it receives from the Sun. The intense radiation environment around Jupiter also presents a significant challenge for any machine sent to study it up close. Yet, robotic explorers continue to brave the radiation belts to bring us these incredible, fiery snapshots. These distant observations teach us about processes that are too powerful or too deep to ever witness directly on Earth. Io's lack of water ice is another key difference, making its volcanic activity purely silicate and sulfur-based. It's a frozen in time. Look at what our own planet might have been like in its earliest, most energetic phases. The sheer volume of erupted material annually could resurface an entire terrestrial planet many times over. It's a constant battle between the tidal forces trying to crush it and the escaping internal pressure fighting back. Imagine watching one of Io's giant volcanoes erupt from orbit, a sight unmatched anywhere else we've looked. The dark, smooth plains are often created by recent, swift flows of extremely hot, low-viscosity silicate lava. These lava flows move quickly, covering previous geological history in a matter of days or weeks. The mountains, however, appear to be formed by materials that resist the constant pushing from below. Io's unique chemistry makes it an early warning system for understanding rocky planet interiors everywhere. The perpetual chaos means that Io is perpetually young, lacking the ancient weathered crusts seen on other moons. Studying the sulfur dioxide frost line helps us understand atmospheric physics on bodies with very thin gaseous envelopes. It truly is one of the solar system's most dynamic and extreme environments, a natural wonder under constant construction. Io's existence challenges our neat definitions of what makes a moon habitable, or geologically inert. We can see the internal heating mechanism playing out live, a geological process viewed across astronomical distances. Future high-resolution mapping will undoubtedly reveal entirely new classes of volcanic features we haven't even predicted yet. The Jovian system remains a treasure trove of natural laboratories, unlike anything we can create here on Earth. Io stands as a powerful testament to the sheer power generated by gravitational interactions in space. So, if you found this explanation of Jupiter's fiery little world fascinating, stick around for more deep space dives. Don't forget to tap that like button if you learned something new about this extreme volcanic moon. And be sure to subscribe right now so you don't miss our next video, exploring the secrets of the outer solar system. Finally, share this wild story of Io's internal engine with any space enthusiast you know. Thanks for watching, and we'll see you next time out among the stars.